Hello and welcome to another episode of the U. My name's Mark Broughton. I'm an instructor here at Cisco. In this episode we're going to look at the Cisco Secure Firewall Threat Defense capability of inspecting GRE traffic. The reason for doing that is it can make the analysis much easier. Now in this demonstration which I'm about to give, we have the following network. It consists of a pair of routers, CSR1 and CSR2, which act as the GRE endpoints. Now the GRE network, it's 172.16.1.0, and CSR1 is the point 1 and CSR2 is the point 2. Now the device in the middle is a Cisco Secure Firewall Threat Defense with the FTD. Now the firewall cannot act as a GRE endpoint. It can allow the traffic to pass through its routed interfaces, and as the traffic passes we can make use of features of the firewall to decide what to do with that inner tunnel traffic. Now connected to CSR1 is a general network which has got the host Attila. Connected to CSR2 is a DMZ network with a host Bledder and Lamp. For Attila to be able to communicate with Bledder and Lamp, the traffic has to pass through the tunnel. Then we can make decisions in the firewall about what to do with the inner headers of that tunnel. Now that the tunnel has been pre-configured, the aim of this tutorial is not to show you how to configure GRE, but namely how we can make use of the features of the firewall to inspect that tunnel. So let's take a look at what we're going to cover in this demonstration. So we're going to start off by initially verifying the tunnel traffic is passing, and we can do that using the firewall's packet capture and packet tracer features. Okay. Once we've done that, we will see what type of events are we seeing initially. Then we're going to make use of the Prefilter Policy to rezone traffic. And once we've rezoned that GRE tunnel traffic, we can add that new zone to our access control rules, and that's going to be really beneficial to analysis of that traffic. Once we've done that, which will require me to deploy some changes to the firewall, then we can verify the inspection of the rezone traffic, again this time using the unified events as well as the packet tracer. Okay, so let's get started. So to begin with, let me take a look at the two routers. Now although these have all been configured already, you can see that CSR1, this is its GRE tunnel settings. There are plenty of good documents on there about setting this up. And here's the equivalent for, you can see that's 172.16.1.2. This one is 172.16.1.1. Now Attila is one of the hosts connected to CSR1, and from Attila I should be able to ping a host connected to CSR2, and you can see that that's working okay. Now if I go back to the firewall, one of the capabilities is this packet capture. Now I've pre-configured the capture, but if I just show you the settings, you can see that I'm capturing traffic on the CSR1 interface, just IP traffic to see what's actually happening here. And then if I cancel that and then just begin the inspection, then we should start to see traffic appearing. I'm just going to not focus on the details here, just set that to tree view. And you can see that we're capturing these packets. I'm going to go back to stop. And let me now try pinging the other host. You can see that that's working as well. Okay, and so here you can see that the captures. So although I'm the ping is from host 50 to host 90, you can see here that it's shown me this is GRE. Now I can expand that. It's shown me it's GRE traffic. So we're seeing the outer header and then the inner tunnel traffic. So hopefully that is sufficient evidence, if you like, that we are passing that tunnel traffic. But if you wanted a second opinion, let me just pause that capture. Another tool I can use is the packet tracer. Now, once again, I've done the packet tracer, but I pre-configured this. But if I try and simulate a packet from the same interface, from host 50 to host 90, basically an echo, a ping, an echo request. If I do a trace of that, you can see that that's not working. Why? Because there's no route from this network to that network. So actually what I'd have to do here is to change that from ICMP to GRE and instead put in the outer header, which is 192.0.1.1 to 192.0.2.1, and then encapsulated within GRE would be that ping. So this is why I can do the ICMP IP4 from 192.168.133.50, type 8, code 0, and the destination IP was 192.168.10.90. And now if I trace that, you can see that that's, sorry, I missed out here the GRE part. Do a trace on that. You can see that that's allowed. And if I change that to 99, okay, so it's not allowing the ping directly, it's allowing the ping to traverse the tunnel. And you can see, things like here, the decapsulation, it's really, really good stuff. Anyway, so what's the challenge with this? Well, if I go to, let's go and stop that ping first of all. It's already stopped. So if I go into this other tool, which is for event analysis, one of the ways for analyzing events is unified events. So if I set that to go live, and let's try a ping of host 90 to begin with. Okay, so that's working. And then if I do a ping of host 99 as well, let's do a few of those as well. Okay, then come back to here. I should get to see these events appearing shortly. Here we go, here they come. But you can see that what's happening is it's showing me the inner headers. That's matching an access control rule. So this was the first ping to 90, that's the second one to 99. I can select the event, okay, but I'm not really seeing anything there that's helping me determine that this is GRE. Okay, so what can we do about that? One of the things that you can do is to go into the pre-filter section, and if you wanted to inspect GRE, you'd have to create your own policy. Now, I've already done this really from a time-saving perspective. And if I edit this pre-filter policy, you can see that within it I've added what's called a tunnel rule. If I open up so you can see this, I've given it a name, enabled it, and what I've done is said that I've made this a bidirectional rule. It could be unidirectional, and simply I've put in the endpoints. So when I showed you CSR1 and CSR2, the tunnel settings, okay, you could see information there. And what I've done then is said if traffic matches these endpoints, then to assign a tunnel zone, which I've called GRE zone. Okay, so that's that. So I've already created and saved this prefilter policy. To activate it, I now go into my main firewall policy, which is the access control policy, edit that, and then in this access control policy, there's a section for prefilter rules. Now I'm going to replace the default prefilter policy, which is always there by default, and replace it with this new prefilter policy. Now that I've done that, I'm going to enable two new rules. So I'm going to select the rules and enable them. What these rules do, okay, is basically say, make use of this zone, which came from the prefilter policy rule. And I've added some objects. In this case, I've said that traffic is allowed. So effectively what I've said is that if we find traffic that matches the GRE zone, then if the target is bladder, to allow, but if the target is lamp, then to block. And then, so what I'm going to do here is to save, and then I need to deploy, and that's going to take a little while. Not too long, fortunately. So while I wait for that to deploy, let me just go back and view those events once again. You can see here in these events, I can get rid of that, but before I enabled my prefilter GRE rule, you can see that initially initially both communication with bladder and lamp matched this access control rule. Now, going back to my policy, that inspect all rule is still there, but these two more specific rules are loaded above. So if traffic matches at first, it's going to match the rule 1 of rule 2 before being checked against rule 3. Let me just go and check if the deploy, how that's doing. Okay, it's still a few more seconds to go, not too much longer. Then we can go and do some more testing. Let me just check that the ping is stopped. It is. Okay, let's do this one first. Let's check if that's deployed. So the deployment is completed. So if I go back to analyze the events, let's resume that. Okay, and now if I try and do a communicate with bladder, that's still working. I expected that. But if I try and ping lamp, that's now being blocked. What's the reason for that? Well, let's go and take a look here. I can see this time the rule communicating with bladder was allowed, but this time can you see it's matching the this allow bladder inner rule, block lamp inner, and if I go and take a look here, the reason is that these later events are matching the analyze GRE tunnel rule from my custom prefilter policy. So it just gives me that greater deal of granularity. One final check is if I go back to my packet tracer, let's try the one for 90 first of all. So that's still working. Okay, but if I try and communicate with 99, that's being should be blocked, which it is. But if I take a look at the the trace, and it said the reason it's blocked is that when we sent up the traffic to snort, it's being blocked against this block lamp inner rule, which is quite nice. But you can see here the decapsulation which occurs earlier. So really that concludes this this tutorial. the aim of it was to just show you that although the Cisco Secure Firewall does not act as a GRE endpoint, it can inspect GRE traffic. And if you make use of the tunnel rules within the Prefilter Policy, you can inspect that GRE traffic and can be pretty powerful. Thank you for watching. Hope to see you in another episode.